comfortable with Ohm's law, power law, and series and parallel circuit, around 60%, 70%, when you're in a good place. So let's go over the quiz and the homework, try to review. Also, you can look up stuff on YouTube. You might not understand it very well from me. Maybe somebody can do a different job explaining it that will be to your liking. And again, I'll give you this piece of advice from somebody who's been in academia for 16 years. If you don't understand something, it's not you, it's the medium. So you might not, and it doesn't mean it's good or bad, it's just like this is how I understand things. Yeah. So try different things. Like there is Khan Academy, there's YouTube, there's probably at least hundreds of people explaining Ohm's law on YouTube or Moore's principle. Somebody you will click with more. People learn differently. Some people are visual, some people are have to watch, some people have to touch, has to play. So find something that's appealing to you and try to work on it. But it's really important for you to understand Ohm's law, series and parallel circuit. Come to me. I can try to maneuver things around and help you understand that. Because everything I built on that it's a very, very basic of electricity. Okay? So we'll cover chapter 5. We'll talk about components now. So now it's not going to be more about math, it's more about remembering things and what they do. So just pay attention, read about them, try to understand what does it do and how does it function. So about components, symbols are how things are put in schematics. We already know a lot of symbols, right? What is the symbol for? This one. Thermostat. What about this one? Low pressure switch, high pressure switch. What about over there? What is that?
Switch.
It's a switch?
Normal switch.
Okay. So you gotta know that at least the basic ones. The fuse, circuit breaker, relay. Not very, very involved. If you go into electronics, there's a lot of things that you will need to know. And basic circuitry of air conditioning and heating diagrams. So we're talking about loads. What are loads?
What's using the electricity?
Yes. Loads are things that use electricity. Otherwise, and what did we say are the basics components of any electrical circuit? Path, source, and loads. If there are no loads, well, there's no point in the circuit, right? So loads, source, and a path, a complete path. Symbols, what do they look like? When in doubt, just put a circle and write what is the component. I did that here. Put a motor. That's it. So you know what is that. And again, are they all universal? No. Every industry have different like symbols for each component. They all are going to be different. Even it's not even about the industry, about the country. I mean, here we use a lot of different gauges, different numbers, different units. So it's going to be different. Symbols and purposes of relays and contactors. What are those? Those are going to be the basis of most of our controls. Relays. We have to understand relays. Relays connect between two circuits. It's a communication between circuits. And as God said, there's a lot of ways you can do in a circuit. There's many ways to be creative when it comes to electronics and control with circuits. This is how we start having computers. This is how we transfer from like big mainframe to smaller computers. The whole idea is about control and signals. So for us, control is a different class. For now, we're trying to work with the actual mechanical, physical big components. Switches, they open and close. And again, those are becoming very, very sophisticated. They open and close based on inputs. So what is the input for the thermostat? What open and close the thermostat? Temperature. So it has a sensor in it, right? What open and close a high pressure switch, a low pressure switch? Pressure. So it's sensing something and opening a circuit. What about this one switch? How does it get controlled? Finger. It's manual. This is the basic, the beginning. When people have to do things by hand, how people used to switch phone lines by hand. I think that was really mind-boggling to look at people in the 60s and 50s. Where there are people with roll blades that go and switch, they connect the lines between houses. That's amazing. That was somebody's job. Like they move around the room, it's like actually switching lines from one place to another. That's amazing. So there was a lot of things that used to be manual. For us, we take things for granted.
So you'd actually have to call them and be like,
Yeah,
hey, can I
connect-
talk to
yeah,
this
kind of,
person?"
You
yeah.
have to make a phone call.
Yes.
Call an operator. The
If you watch some
operator
old
asks
movies,
you
man.
Where you wanna connect to.
Yeah.
And then she said.
And you
"Oh,
say,
I'm
operator?
sorry, you come back."
Yeah, you listen to the phone, you say operator, and then connect the number, and you go and put it in.
Public phones were real.
Oh, yeah.
Oh yeah, from the quarters, and you go there with big roll of quarters, it's like you put in quarters in there.
You have to carry quarters wherever you went.
Dude, seriously, what if the cell phone companies are scamming us, so there's no more phone, like, what do we do? There are no more paper
They
ones, right?
took them all out when I was like 4 years old or
No
something.
more paper ones.
There's
There's
none.
one somewhere.
They're
Huh?
very rare,
One I've
very
seen
rare,
somewhere.
usually gas stations or rest stops, or like maybe like a train station. Wow.
There was one on, at that gas station on State Street, near Stick, actually.
Yeah.
That little small one.
Has it paper one?
Well, if they don't have the quarter, then
Oh, I don't
your
know
card
if it
reader.
works. I've never tried
You
it.
use your card.
Okay, okay.
All types of things.
Nobody wants to touch
Things have changed a lot based on like manual operation to electronics and sensor and switches, and it's for the I think it's better. The more you have, well, I don't know, it's the rise of the machine. Skynet is coming.
Well,
So
there's-
everything is being controlled by automation. So I don't know, but things used to be manual. They used to have in power plants at least a team of 4 operators. Now they only need 1 operator. Airplanes used to fly with at least 3 pilots. Now they only need a pilot and co-pilot. No flight engineers. Anything is done by computers. In trades, we have more reliability and more accuracy, less area of error. Also, you have people who can hack into it. But anyway, business controls, different wiring diagrams in the industry and how they are used. So how do we look at diagrams? You will have to read diagrams. They are not going to be voodoo or something confusing. We will learn how to look at a diagram. A diagram is just like your map. It's a map for you to read. And when you look at the map, what do? You guys don't even use maps anymore. My examples are all obsolete.
You gotta,
Key?
Huh?
first thing, you gotta locate yourself in the map.
That's great. Then what?
You know, that you find your
When we took geography back in the days, we had a class that teach you how to use a map. How to use a map.
I wish.
Find yourself. Find
Riding up.
which is find your north. So you align the map to the north. You find yourself, and you find landmarks. That's a lost art. So this is I think it's scary. too. We don't use maps anymore.
I still
Yeah.
carry one. Just in
Huh?
case.
Yeah, me too.
Still carry
I
one.
did not buy GPS until 2 years ago. I was always doing maps and easy stuff. Okay, do you know that the highways actually tell you the direction? Like
Yeah, east to west.
even numbers are east to west, and odd numbers are north to south. They have a lot of technology in it.
I never-
Old navigation
I
systems.
never noticed that. I noticed that. God.
Yeah. So
That's
see?
crazy.
we used to rely on that a little bit, and if the number decreased certain way, you're going east, you're going west, because we used to rely on maps a lot.
That's all you had.
Yeah, and that's why I was looking for a place in Springfield, Illinois, and I thought it was in Springfield, Massachusetts. I was matching street names, and I after 3 hours looking for the place, I stopped at the gas station, and I was like, showed the guy the map, like, this is Springfield, Illinois. You are in Springfield, Massachusetts. Whoops. So that's why Springfield's very confusing. But anyways, so things are getting more sophisticated, easier, but again, we're losing a lot of abilities, I guess. Loads, devices that uses electricity, to keep that in mind. Examples, motors. We have to understand motors. I will take 2 weeks talking about motors. And in the lab, you'll take one apart and put it back again, just to get acquainted with motors, because motors do a lot of the work. And when you do your project, you'll see that most of appliances are basically motors and heaters, and this is just controlled. Resistance heaters and other current consuming devices, but mostly these are two actually, motors and resistance heater are the lead in power consumption. Most important part of heating, cooling, and refrigerant systems is those things, and they perform all the works. Motors, heaters. A motor runs a compressor, runs a fan, pump, so it does all the physical work. Okay? These are some of the major loads that you will see. Motor by itself, that's a spinning shaft. This is a motor on a pump. It's a water pump, fire pump. It's red. The pump part is this part over here, and this is the motor. The whole thing is a motor and just a pump. Hermetic compressor has a motor inside. It's called hermetic because it's completely covered, but there is a motor inside and a small compression chamber.
Are those like
I
the
see one of
K?
those.
Huh? What?
No, I was gonna ask, are those like the K-body compressors?
I don't know, they're called hermetics. There's one in the back if you want to see. This is a hermetic.
Oh, no, I was talking about the bigger ones for, refrigeration.
Oh, I don't think so. These are sealed.
I had no
These are small and sealed.
I seen one for the first time, one of our older units.
Yeah?
Yeah. I opened it up, I was like, what the fuck is this thing?
Language. So, this is a hermetic compressor. It has a compressor side and completely sealed because you don't want to use refrigeration. This is a solenoid. So basically, inside this wrapper, there is a wire wrapped around. What does happen with a wire when it gets wrapped around? It creates what? Magnet. So this energizer can pull in or out a stem, and you can get creative with that. What would that do? That can open and close a valve. Can open and close a switch. So again, we're trying to make movement out of magnets, and this is one of the ways to do it. What about this thing?
Heat exchangers.
Huh?
Heat exchangers.
It can be in a heat exchanger, but this is actually a heating coil, electrical heating coil that can heat air. So has smaller coils in it. You run current through it, and it gets really hot and red. Probably have something flatter in your oven, in the bottom. Your stove has something similar to that. They get really glowing hot. Okay, motors. This is one of our biggest concern. We are not going to fix motors. We're not going to take them apart. We're not going to make them. But it's important for us to know how they function, because the function of a motor is the function of the entire HVAC system. So they consume energy. They rotate devices. They rotate a compressor. They rotate a pump, a fan, and so on. So and they have different types of those. And the advancement of motors led to a lot of advancement in electronics and in equipment. Things get smaller, more efficient, more power, more torque. I will talk about that. They consume most of the power by far in any refrigeration system. Okay. Now we have abilities to use motors in cars. That was something unheard of. But now you can go to Tesla and it has 4 motors, small motors at each tire that provide enough torque for the car to accelerate from 0 to 60 in 3 seconds. That's new. Like the motors got really advanced. And again, all it does is convert current efficiently into magnetic movement that propel things around. So it got really more efficient, consume less power, you're making the most out of your amperage. Also, what pushed for the advancement in electrical cars and motors are the batteries. Batteries got really much better, and ability to store energy. These are some symbols of motors. Again, when in doubt, you're always gonna see a circle with a symbol inside. Condensified motor, evaporator motor, they're all motors, and they all look the same. This is another way to draw a motor. When you get them, you just put a circle and put what kind of motor is that. Okay, we'll spend 2 weeks talking about types of motors, how they function, how you distinguish between them, how would you know the rotation. We'll talk about that in a lot of boring details. Solenoids. What are solenoids? Solenoid is a coil. There's a steel bar in the middle. The coil has current going through it. It generates magnetism and heat. And when you put an iron core inside any coil, it becomes intensified. And it will be able to pull or push that pin in and out. So we use solenoids to control valves, open a valve, or close a valve, which is a good way to open and close things, not manually. Again, we used to have a lot of manual switches, you have to close and open it by hand. Now things can be opened and closed in a very, very sophisticated way from far. Even in big power plants, they have valves that can open and close remotely. So in your oil burner or gas burner, there is a solenoid valve that open and close. And again, when you turn on your car, not completely go to the on position, you hear at least like 4 or 5 clicks. All those are solenoids, one for the gas, one for the air, and what have you. They all click to open right away. It's all electronics. It's not like it used to be back in the days where everything was mechanical. Now it's completely electronic. And again, they get more and more efficient over time. So they open and close, can close the machine in an electrical component, a relay or a valve. It can open a relay, it can open a valve. Considered to be loads because they do consume some energy, but not as much as motors.
Are contactors solenoids technically?
No.
No, they're different.
Contactors, they have a coil, but they're not solenoid because
They're not controlling pressure, or is that?
there's no moving part that closes and opens a valve.
Yeah.
Yeah, but I can see why would you think that.
Because the whole electromagnet.
Yeah, yeah. This is a solenoid valve that is placed on a gas line. Probably if you have hot water system, you have one of those solenoid valves. What it does is, again, there's at the top, that's the solenoid. Put that one wrong. They work. All this gold, man. They don't make them like they used to. That's another one. So they can open and close the flow for gas, oil, and water. And that became very, very important. Unit of control. They connect to a thermostat, they connect to a control. So your car, you have plenty of solenoids. There's one that control your gas. There's one that control your air. There's one that control the coolant. There's thermostatic valve as well, that open and close with temperature. So, does anybody work with cars? I use a lot of car metaphors, by the way. I don't know.
I want to.
Crazy, but I know my way around.
I grew up working with cars, so I can always use that. And I feel like everybody have a car, so you can always be in touch with it. Let's see. Heaters. What is a heater? It's a very intense coil. Different material again. You had copper that create a magnet. Different material, when you run current through them, they become hotter and hotter. So eventually it will heat up, and that's what you have in your stove. It becomes very red and glowing. Usually it's tungsten, and I showed you the filament in a light bulb. It's basically tungsten filament that gets heated up to a point where it completely glows. It converts electrical heat to energy. Electrical energy to heat, and it's a resistance, so it consumes a lot of resistance. It's efficient in a way that all the electricity that comes into it becomes heat, but it consumes a lot of energy. Like at some point, they decided that for all new constructions, we're going to use electrical ovens because it's much safer than using gas. And they compared the cost and said, okay, based on the average cooking person, it's much safer and made more sense for us to use electricity for cooking than gas. Because gas can be very problematic in terms of leaks and issues of that such. This is what the symbols for coils usually it looks like resistance, and again you can always label it by heater. You will face heaters or have to work with them in electrical heaters, some AC defrost cycle, because if the AC accumulates a lot of heat, you need to run the defrost. If you work in an ice machine, probably have a heater. Your freezer have a defrost cycle, which includes a heater. So again, you will have to work with heaters, and sometimes you have to change them. Signal lights, those are mostly LEDs. They're very good to tell you if the equipment is on or off, especially when it comes to electronic boards, where it's really difficult to go and measure the voltage. So signal lights come on and come off till this circuit or sub-circuit is on. And sometimes it's indicating if it's on and off, or also the situation. Either on standby, and so on. And they come in different colors. And sometimes the same LED will change color, but they are very beneficial for.
Are those in the, like, the AC units and stuff like that? Cause I see them a lot.
Yeah,
in
yeah,
the furnace system. I
A
see
lot
them.
of boards have lights in them now to indicate. Now they switch from boards to what, from lights to what? What do they use now instead of lights? Lights are the past now. Now if you go to new controls, what do you see? What does your car have now for control, for indication? Remember back in the days, the AC
Is that like a
has.
code?
Huh?
Usually like codes.
Yeah. So again, going back to the car example, cars in the 80s, there was no lights, there was like switches on and off, manual. You put it on, you put it off, right? Then we got to the 90s and there are cars with toggle switches. You turn it on, it lights up. It says AC is on, heater is on. Now what do you have?
Digital readout?
We have a LCD now. We don't need any of those things. The LCD would tell you what's happening. AC is on. This is the temperature. This is LCDs everywhere. So if you go to control big boilers now, they have the LCD touch screen and everything. So no need for like all this electronics. It got cheaper. And I mean that the controls and the processor are very small. Like there was a time. I'm not sure what it is. Like this is the. Evolution of primary control. So this is the first generation. One button, everything connected once and on all the time with one wire. That's it. That was actually the code until 5 years ago.
There's an older one than that.
This is as old as me.
That's what I remember, like a gray box and it had the red button underneath. You just had to press that one, it had nothing, it wasn't like that.
Now this is for residential. It's always been there. This is for the last 4 years. Second generation was these ones, which again still has one LED and a toggle button and more wires because I have more timers inside. So we don't have to turn on everything at once. Then this is the new generation now, which is current, which you have no lights, LCD screen that tells you what's happening. It will verbalize whatever it says. Heat is on, flame is on, beacon is on. It's much nicer and easier to communicate what's happening. They have a newer one now that goes with Bluetooth. So everything's gonna be 3 or 4 now. It's again, the more we make these things, it's more control, but also there's always loopholes to it. But I'm all for automation. It saves a lot of things, and it reduces human error. A lot of issues are human error. Somebody leaving things on, leaving things off, instead of going with a checklist of things to do, everything is like self-check. A lot of safety devices happen in a lot of appliances. Now coffee makers turn off by themselves. They used to cause a lot of fires. Somebody forget the coffee maker on. Now after 15 minutes it will shut off by itself. It kind of prevents a lot of issues. Okay. So I will stop here and I will finish talking about